Now let's see how we can actually address these problems. So right now we know that I know that we don't have any problems with the random vibe or mechanical shock, but if we did have problems with this, we actually, you know what? Let's go ahead and change our mechanical shock to something. I want to just modify this that gives us a problem. Let's just change this peak load from 32 Gs to 100 G and apply. There you go. It is there. Save. Let me rerun mechanical shock here. Edit properties, save and run. Just give it a few seconds to run. While we're waiting for that, let's look at solder fatigue. So we know we do have a problem here. Our solder fatigue is failing at a little less than 2 years, and our plated through hole fatigue is failing at a little over 2 years. Solder fatigue and plated through hole fatigue is due to CTE mismatch between the board and the component for the solder fatigue, and between the board and the through hole for the plated through hole. So the smaller the gap is between the CTE between these two, the better results we get. Now for our mechanical shock that is done, we can see now we do have failures. Some components are failing almost right away. How do we address these problems? So if I go to my natural frequency, right click, and go to view 3D results. The 3D result window is going to open up. And let's just wait for it to run. There you go, it's here. You can see that our natural frequencies are listed. So if I click on the first mode and refresh, you can see how the board works, right? So if I minimize the warping, it's too exaggerated here. There you go. So you can see how the board works, right? In the first mode. So you have the max displacement right in the middle. Let's look at displacement on the second mode. There you go. You can see the max displacement is right in these two areas. How do we address this? So of course, if I add a mount point in the center and 2 mount points in these two ends here, I'm going to get a better response. Let's try that. Let's close this. Let's go to our layer viewer. Let's go to edit mount points. I can either right click, add a mount point, which I need to fill in all this information, or I can right click on one of these mount points that I already have and copy a mount point. And then I can drag and drop it right there to make it simple, right? Let's put one right in the center, and then let's copy this and then put one mount point right on top here. One thing we need to know is that the mount points needs to be inside of our outline. Copy mount point and then bring it here. There you go. I know it's too close to components, too close to outline, but this is a hypothetical case. So save, minimize this. Let's go back to our mechanical shock, edit properties, save and run. Right click, edit properties, save and run the natural frequency, and let's see how the results have changed. And meanwhile that this is running, to not forget about our solder fatigue, because I don't have a good memory, I want to save my results. So what I do, I will click on this result menu to open up, and I will right click and save results. And this will save whatever analysis that we have done, it will save the results in there as well. So if I now go down here, double click on the saved results, it will open up the result window. And while we were waiting for that to open up, or actually it's opening up already, so let's just give it a second here. There you go. So the solder fatigue result that we have from that previous analysis, it's here. So I want to keep this on to compare my results when I update my board. Now, mechanical shock and natural frequency is done. Now you can see the natural frequency has increased from 190 to 630. So usually the higher your natural frequency, the better response you get from your mechanical shock and vibration. And shock problem is gone, right? So that's one way of doing addressing your problem. I know you probably cannot just add a mount point to your board wherever you want to, but you can see how quickly I added a mount point, and then you can go to your project managers and talk about things that you need to change to get a better result. Next, let's address the solder fatigue and plated through hole problem. So right now, I'm using a very generic FR4. What happens if I change my FR4 to something that is more expensive? So let's just highlight all of my laminate, edit selected layer. So instead of a generic FR4, let's use something that is a little bit more expensive, 370HR, save. And you can see my CTE has changed from 17 point something to 14 point something. So I think I'm going to get a better response here. So let's see. Right click, edit properties, save and run on solder fatigue. And let's run plated through hole fatigue as well. Edit properties, save and run. And it is done. Let's look at our result. You can see I already have much better result here. If I compare this against my previous result, let me open up the result window. I already have much better response. I know it is failing faster, but I get less red components here. So let's bring this guy here. Let's put it here. Let's compare this against solder fatigue. You can see that on the right-hand side, I had the previous FR4 generic FR4 result, and this is a 370HR FR4. I have much better or more green or more yellow rather than having more red. And now let's look at our plated through hole. You can see it's all good now. And the plated through hole previously was failing at about 2 years. And now I don't have a problem anymore.